In today's adventure, I plan on doing a modification to my four-wheeler Beastie. What I intend to do is I have a light switch that differentiates between off, low beams, and high beams. The low beams are located on the front here. I've already modified them to LEDs. The high beam is just in this headlight pod. Again, I've already modified it into an LED. But what I don't like is that the low beams are just these lower lights here in front, and the high beam is just this upper headlight pod. So when I'm plowing and I want high beams, really what I'd like the four-wheeler to do is have the low beams and the high beams on. Now, from a logical function of how the electronics are set up on this particular four-wheeler is that it's one or the other. And if you modified the switch to connect both circuits together, regardless of whether you had the high beams or the low beams on, they would both be on. Now, that's not what I want. Sometimes I want just the low beams on, but when I want the high beams on, I want the headlight pod here and the low beams on. What I've noticed is in Polaris's Infinite Wisdom, future iterations of this machine actually already has that built in. So how convenient is that? They fixed the problem for newer machines. With older machines, it isn't very straightforward in how to do something like this. So this is an '04 Polaris Sportsman 700 EFI. And what I'll need to do is install an independent logic function into the electronics of the headlights here so that when I have the high beam on, it also kicks on these front lights as well. So did some internet research and found out that the tool that I need is called a diode. So a diode is basically like a one-way switch. It allows electricity to go in one direction and not the other. And so that is, I think, going to be the tool that I need from the switch, which has the wires in the headlight pod, to let the electricity or the flow of electricity logically go from this unit to the low beams when I have just the high beams on, but not the opposite way around. So I went online and just bought a little super tiny, I don't know if this will pick up very well or not, but just a little diode here that's going to allow that logic function. So in today's adventure, I'm going to crack open this headlight pod, find the electronics that control the high beams and the low beams, and try to put my logic function diode switch in between so that it operates the way that I want to. Now, I've never done this before. I've never used a diode before. I've never tried modifying the wiring system of a four-wheeler before, so I have no idea how this is going to go, and you can join me in today's adventure. Okay, we'll start by taking me out of the focus and focus on the headlight pod, which is where all the magic happens. A little bit of background on this particular machine. I bought it online. It was heavily used and abused before I got it, and had to do a tremendous amount of labor replacing things. So being an '04, what I found was the headlight pod, or this section of the machine, is not actually manufactured for '04 anymore, so it's kind of left in the dark. Did a bunch of research and found that actually an '05 headlight pod fits on the same frame as this '04, so I was fortunate with that. But just something I had to find out through trial and error. A little upsetting that they didn't make it for this machine anymore, but good that they still made the '05 to fit. So those who are really astute watching this video and heard me say that this is an '04, and they're like, "Wow, this headlight pod looks newer, or looks like an updated model, almost like an '05." That's because it's an '05 headlight pod put onto an '04 machine. So that is a very nerdy aside. But I'm going to open this up and we are going to find and test the electronics coming off the switch up here that differentiate between high, low, and off. So we have to find where the power cords are that's energizing the high beams, energizing the low beams, and then find a way to splice this in between, and we'll see how that works. All right. So I could look online to figure out where everything is, but I like to think about things logically and test them out myself. Sometimes wiring diagrams are hard to read, and sometimes they're difficult to find, or you get yourself in trouble trying to look up the right diagram because there's a lot of nefarious websites out there. So we could skip all that stuff just by doing a little logic function testing out here. So um, I am going to take my test light, just basic test light for a 12-volt system. When it connects a circuit, it's got a little light in here that tells me that there's a circuit that's completed. But I can also use it as kind of like a jumper wire. So I know that headlights turn on when they receive power from the battery. That is going to be dictated by the switch. There's two plugs coming out of the switch here. Um, One is for the stop run speedometer reverse function, and the other one is going to be for the headlights. And I just used a little logic and figured that the headlight one probably had more wires coming out of it and was located closer to the switch as opposed to the stop run function. So I just took this one out. It is green and crusty, so I'm going to clean all that up before I put it all back together. Put a little dielectric grease on there and hope that it's going to survive a little while. But I think that this is the one for the headlights. And um, they tried to cover up and protect these wires probably, in '04, which is 20 years ago now. So the covering's starting to crack off. But this is where I want to be working with the wires anyhow. So is it this bundle or this bundle? The colors match in this bundle, not in this bundle. So I'm guessing that it's this bundle right here. And I'll remove some of that covering, protective covering, and I'll put it back when I'm all done. If I'm going to be manipulating wires inside this headlight pod in this little area here. But I got to figure out which one of these colors is actually doing what function. Um, so I have this connected to the positive end of the battery on the four-wheeler. So basically I can send positive power to whatever this pin touches. And I can just start at the beginning, and I can poke this, and it might be a little bit off camera, but when I put it in this first pinhole and apply power to it, I'm flipping on my low beam lights. So take it out, low beam's off, put it on, low beam's on. You might not be able to see it, but I can see it blinking at me. This one you could probably see a little better, the next one over. I'm going to just poke that, and I can see, hey, now I have my high beams. So when I apply power to this, that's saying whatever switches are in here and are moving around, when the switch puts power to this pin, I have high beams. When the switch puts power to this pin, I have low beams. So we can just go back and take a look at the colors. My low beam switch is going to be the green wire. My high beam switch is going to be the yellow wire. So I'm going to open this up, take some things out of here so I can have a little bit better access, and we'll go poke around with that in a little bit. All right, we're going to dive a little further into nerd land just to prove the proof of concept here. Get this out of the way so it doesn't confuse everybody, including myself. So I have the diode that I was showing earlier. They were kind enough to put a little red tape on one side and white tape on the other to say, hey, this thing has some directionality to it. No instructions came with this thing, so I just thought I'd think about it a little bit and actually do my own testing to see if I can figure out how this rig works. So I've set my multimeter here to DC current. So basically, if you look at a battery and you plug one side and the other, one side and the other, positive to negative, it will tell you the DC voltage or the direct current voltage of this battery. 12.53 looks like a good battery. So same concept, except now I'm just going to pop this diode into the system and see which side does what. So I'm just going to go ahead and complete the circuit here. I'm going to put the diode in between with the red side pointing down, and on the positive end of the battery, and my tester on the negative, and see what the result is. So I got 3.3-ish volts when I touch it to the battery in that orientation. 3 volts is more than I'd like. I would hope that it would have been 0, but what do I know about diodes? So flipping it around, red side up, connected to the positive end of my tester, black end to the negative side of the battery. We're just going to go ahead and touch these again. And now I've got almost full voltage, 12.1 volts, going in that direction. So this means to me that the orientation of this diode is that it will allow, or is designed to allow, electricity to go towards the red end of the diode and not the opposite way around, and that's the logic function that this is supposed to work with. So let me just bring you back over to this mess that we have going on over here. All right, this looks like a glorious mess, and it really is, but bringing you back to our conversation here, I took this plug out, I tested these plugs. Green wire is low beams, yellow wire is high beams. Took a bunch of the zip ties off so that I had a little bit to work with. There was already a natural break due to age in the protective coating on this, and I'll put this back when I'm all done. But gave me a chance to liberate some of these wires and have a little bit more room to work in here. So again, green and yellow are the wires that that are from the switch that energize the headlight pod and the low beams. And so if green is the low beam and yellow is the high beam, when I energize the yellow wire, I want electricity to flow to the green wire. But when I energize just the green wire, I do not want energy to flow to the yellow wire. So that being said, I know the flow goes towards red. I want to splice this diode into the yellow wire, pointing towards the green wire. So white end in the yellow wire, red end towards the green wire, so that when the yellow becomes energized, I'll get voltage that runs through the diode and pushes it into the green end, illuminating the low beams. When I energize the green end, just the low beams, energy should not be able to go back through here and energize the yellow end. So now I just got to devise a way to plug this little diode into these wires without causing too much damage or corrosion. So let's see what I can come up with there. All right, you guys are gonna love this. With every project, there seems to be some sort of learning curve, and again, just because I'm trying to logically flow through this, I had my light switch unplugged. I talked about the green and the yellow wires here, so I decided instead of splicing them in, I would just cut the wire. I would take the diode, I would solder it in, and then I'd put heat shrink over the whole thing just to seal it up and give it a nice waterproofing. But I wanted to do a proof of concept first before I tighten everything up, because I've made that mistake in the past where you put everything back together and you made a mistake and you got to tear the whole thing apart. So I had the light plug unplugged after I was able to test and verify these wires. And then when I went to go start the motor and make sure everything was okay, do kind of a final run through and check, nothing worked, and my heart sank. So I was like, oh, well, I was fiddling with the electronics. And word of caution here, anytime you're going to connect to the battery and have 12 volt live power and prodding an electrical system, if you make a mistake and if you cross the wrong wires, you will cause a fault or a short somewhere and possibly blow a fuse. So first thing popped into my head, oh no, I blew a fuse. So I had to take the front cover off, get to my fuse block. I tested each one of these fuses individually. They were fine, but they were filthy. So got in there, cleaned it all up, greased, put dielectric grease on everything, put it all back. So I kind of did myself a favor, I think, by digging around in here. Still didn't work. heart sank again. I was like, oh, I went to go fix my headlight, and in the process, I've destroyed my four-wheeler by blowing something up that I don't even know where or what it is. So I started tracing wires, and then I had, every now and then you got to step back and think a little bit and say, what did I change? And the thing that I changed is when I unplugged the switch from back here. Yeah, there's a lot of happenings here. So this is the switch that I'm looking at manipulating off, low, high. But in this whole cluster, there's also the kill switch, the off, run, off engine switch. What are the chances that the plug that has the high, low, and off settings also is attached to that kill switch? Well, turns out pretty good. Um, and when I plugged the the wires back in here, everything started working again. So that's when you have this plug unplugged, it cuts the power to the machine just like the kill switch on the front side of this thing. But that was filthy too. So cleaned that up, plugged it all back in, and then I just ran a little proof of concept now that I was assured that everything was working properly. I dropped this little devil into the headlight pod and had to go fishing it out because that was something. So again, what I wanted to do was white end here on the yellow wire, red end here on the green wire. And in theory, then if I could put this here, just kind of hold it in place for now, and then fire it up. I got low beams on low, high headlight pod is not on, and then high beams on high, and my low beams are still on. So that is exactly what I need it to do. Now I just need to attach it. Okay, more updates. As you can tell, I just went with standard butt splices instead of soldering it in place. Why did I do that? When I was testing it, I found that diode got extremely hot fairly quickly, to the point where I was a little bit concerned about it, burning my skin. So I'm not convinced that this is going to work for very long. And I may have to find an alternative solution. I did a little rabbit hole digging on the internet, and everything that I can see says they just used a 3 amp 12-volt diode and they're as happy as it can be, and then the post kind of stopped. So we'll just assume that getting really, really hot and being as small as it is inside the headlight pod will cause nobody any trouble. I would guess that if it got too hot, it would melt a wire and kill the headlights. So I guess for now, I'm all right with just using the shrink wrap and shrinking everything down over that diode. It does work, which is pretty cool. So with the four-wheeler on, I can switch to low beams. I don't know if we can see that okay, but low beams turn on, and then when I switch to high beam, my high beam turns on and my low beams are on. See if I can catch you both at the same time. See, high beam, low beams, just low beams, no beams. And that's all being controlled by that little diode I put in here. But when it's on for a long time, and I just tested it for about 20 minutes as I was um, searching the internet for solutions or answers or see if anybody melted their four-wheeler, this thing got unbearably hot. Like, you don't want to touch it hot. So I'm hoping, just because it's kind of floating around in that headlight pod, that that will be okay. Otherwise, I'll have to update this post and let you know if I started my four-wheeler on fire or blew a fuse or something like that. So for now, I'm gonna shrink her up and close her up and put her all back together. We'll see how that looks. All right, so how did it turn out? everything's working the way that I had hoped it would. I have low beams and high beams on when I have the high beams on, and I can switch it just to low beams when I want the low beams on. So modifications seem to work just fine. A couple of hiccups along the way, of course, always something to be learned here. Don't freak out if you unplug the high beam, low beam light switch because it controls the entire machine and you won't be able to turn it on. So that's got to be plugged back in. Um, Gave me an opportunity to clean up some fuses. That was kind of cool. And I learned how diodes work and that they can get extremely hot. So I'm going to monitor this throughout time when I'm actually using it to see how hot does it get, and is it going to actually cause any damage to the inside of this, or is that just part of the process and it dissipates the heat well enough that it won't melt anything, fingers crossed. Again, I tried looking it up online, and all the posts kind of just terminate and stop saying, it gets hot, but it's fine. So presumably everybody's ATV hasn't melted that's done this. It's extremely inexpensive to do as long as you got a little know-how and some wiring skills. I don't know if I'd classify myself as one of those people, but it seemed to work out in this particular case. So I'll continue to monitor it, but I'm going to call this project done and a success for now. And with that, thanks for joining me. Join me next time if you liked what you saw, or even if you didn't, like and subscribe it. Appreciate you. See ya.